Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hi, everyone. Thank you for joining us for the Oxygen Talk, which is proudly brought to you by the Oxygen Alliance. My name is Mwawi Lungu. I am currently in Lilongwe, Malawi, and I would be very happy to also know where each and every one of you is joining us from. So please just paste your name, your location in the chat, and then we'll be able to know where you're joining me from. So in case it is your first time joining these Oxygen Talk calls from the Oxygen Alliance, these are calls that we normally host every second and fourth Thursday of the month. So we have one call which is done by our partners, so we invite a guest, and we have other calls which are done by our biomedical engineers from OpenO2 and Sunrise. So speaking to us today will be our biomedical engineers from OpenO2. Some of you might be wondering where our friends from Sunrise, so they are running a training, and so they have been tied up for a couple of weeks, but they will soon present to us. So before we jump into the session, remember that we have a Facebook page and a YouTube channel. Please make sure to follow these platforms so that you can get a recap of all the material that we have produced in the past. So our engineers today will be sharing to us on the topic of oxygen splitters, as we saw in the invitation email. So please, let's pay attention. And if we happen to have any questions along the way, let's just note them down, and then we ask them towards the end. Or you can just paste them in the chat, and I'll make sure to keep them, and then we'll work on those questions at the end. All right, so reaching this far, I will now hand over to the OpenO2 biomedical engineers to take us through that presentation. So to begin with, I'll hand it over to Grace. So over to you, Grace.
Thank you, Mwawi. Hello, everyone. Once more, welcome to our today's discussion. As stated in the topic, I and my fellow engineers will tell you more about oxygen flow splitters. This presentation contains a background description of flow splitters, followed by their general description and technical specifications. We will also share with you more details on how to use and care for them. And finally, we'll share with you some problems that are commonly encountered when using flow splitters and how to deal with them. Flow splitters is one of the health technologies that is being used in hospitals as a way of delivering oxygen therapy to patients. As you may note that many health facilities in low and middle income countries have emphasized the shortfalls in oxygen availability. The demand for oxygen is high than the available functioning oxygen delivery systems due to high population and economic problems. COVID-19 is one of the reasons that led to the increase in demand for oxygen. As such, use of flow splitters ensures a reduction in power consumption, as only a single or few oxygen machines can be powered when there are more patients like infants who are requiring oxygen therapy. This is in the case where oxygen concentrators are being used as source of oxygen. There is also a reduced congestion of oxygen devices in the wards when using splitters because only a single oxygen source can be used. Additionally, because there is no movement of oxygen supply when using splitters, some infections may also be prevented. I have mentioned more about flow splitters, but what are flow splitters? Flow splitters are accessory devices that divide oxygen from one source to several patients at independent adjustable flow rates, depending on the required dosage for an individual patient. Depending on the model of the splitter, their maximum flow ranges from 1 to 2 liters per minute on one output. Note that flow splitters can be used with oxygen concentrators, oxygen cylinders, or piped oxygen. They may also be combined with CPAP if the oxygen source and the splitter flow meter have the capacity for the flow rates required. In Malawi and many hospitals, flow splitters are particularly being used for newborns who are only requiring few doses of oxygen. Many conditions that affect babies in the first days of life can result in low levels of oxygen in their bodies. Infants suffer from hypoxemia, a low level of oxygen in the blood. This is a life-threatening condition that results in increased mortality and morbidity. Prematurity and respiratory distress syndrome, pneumonia, and other severe infections and difficulties in the transition from fetal to neonatal life can all result in hypoxemia. I will now hand over to my colleague, Kelvin Saidi, who will take you through the general description as well as the technical specification of flow splitters. Over to you, Kelvin Said.
Thank you very much, Grace, for the introduction. My name is Kelvin Saidi, and I'll be taking you through the general specifications and the technical descriptions of these oxygen flow splitters. So, as my colleague Grace has already said, oxygen splitters play a vital role in medical settings, dividing a single stream of oxygen into multiple pathways to save multiple patients from a single oxygen source. So by utilizing these ingenious devices, the cost of oxygen delivery per patient is significantly reduced while conserving variable resources. So the fundamental design of an oxygen splitter comprises of an inlet port that connects to an oxygen source. So this source can either be an oxygen concentrator, an oxygen cylinder, or piped oxygen. So it also has 2 or more outlet ports that connect to individual patient breathing circuits. So these splitters intelligently distribute the oxygen flow, adjusting the ratio based on each patient's unique needs. Now let's dive into the technical specifications. I'll begin with the flow range. So oxygen splitters typically offer a flow range of 0.1 liters to 2 liters per minute of oxygen. And it ensures precise oxygen distribution for various oxygen therapy applications. When we are talking about the inlet connection, the inlet connection of an oxygen splitter commonly features a standard medical gas DISS fitting, and this guarantees a secure and leak-proof connection with the oxygen source. So the image to your right shows how a DISS fitting looks like, and I'm sure most technicians on this call have come across this one. After talking about that, let's look at the outlet connection of these oxygen splitters. So the outlet connection enables easy integration with the nasal cannulas, masks, or other commonly used delivery devices in any healthcare setting. So the bulk fittings are the most commonly used connection for these outlet ports. And the image at your right shows how a bulk fitting looks like. And I'm sure most of us have seen something that looks like this as well. When we are talking about the accuracy, so most oxygen splitters boast an accuracy of plus or minus 5% of the labeled flow rate. So this ensures precise and consistent oxygen distribution to each outlet port. So if you do this, you are meeting individual patient requirements accurately. The number of ports for an oxygen splitter it varies with from 2 to more, or 2 to 5 or even more outlet ports. So this just depends on the model of the splitter and the manufacturer. So you might find some oxygen splitters with 4 outlet ports. You might even find some others with 8 outlet ports. So it just depends on the model and the manufacturer. The materials that are used, most oxygen flow splitters are constructed from medical grade materials such as durable plastics or non-reactive metals. And this ensures compliance with safety standards and suitability for use with medical gases. Now let's talk about the safety and standards. Yeah, so when you are considering an oxygen splitter or any medical device for that matter, it is essential to prioritize safety and compliance to standards. So when you have the splitter, you have to look for certifications like the CE marking, the US FDA approval, or recognition by any strict regulatory body in countries such as Japan, Australia, or Canada. So these certifications not only establish the device's reliability, but they also instill confidence among doctors and patients. So it is crucial to select an oxygen splitter that holds at least one of these certifications. So the image to your right shows how a CE marking looks like and how an FDA marked device looks like. So that's the logo for that the FDA uses. So other considerations you have to take to heart are that the specific technical specifications can vary depending on the manufacturer and model of the oxygen flow splitter. So if you want a detailed and accurate information, consulting the product documentation or contacting the manufacturer directly is highly recommended. So this will assist you in selecting the ideal oxygen splitter that perfectly caters your needs. So this is the end for the general description and technical specifications. Moving on, my colleague Goodluck Banda will take you through on how to use these oxygen flow splitters. Thank you, and over to you, Goodluck.
Thank you, Kevin, for that wonderful presentation. So now I'll take you through the usage of flow splitters. So for one to use an oxygen splitter, they have to know how to prepare it, how to do some checks, and of course, how to adjust the device. Now, let's start with how we can prepare our device for use. So if you want to use an oxygen splitter, you have to press it on a stable surface or attach it on a wall. So we do not want to have unnecessary force or jumping over of the oxygen splitters. So if you want to mount it on a wall, make sure that you check the back cover of the oxygen splitter to see the holes on where you can attach your flow splitter to the wall. And when you put it on a table, make sure that it is firmly set on the table, so you don't have any necessary movements. When you have done that, you have to open the regulators on the flow splitters. Make sure that you open all the regulators on the flow splitters. Once you have done that, it's time to connect your flow splitter to the oxygen source. So in our case, we have oxygen concentrator, which is giving oxygen to the flow splitter. So you have to make sure that the tubing connecting the flow splitter and the oxygen supply is tightly fixed to the Christmas tree shown on the left on the slide. So the Christmas tree connector is the one shown in green color. So you make sure that that is tightly connected with the tubing, and that the tubing is also tightly connected to the oxygen spreader. Once you have done that, you have to turn on the oxygen source. Now let's look at how we can check our oxygen spreader. So you have to lead all the flow meters of the spreader. Make sure that the balls in each flow meter have loosened up. So in this case, you may have blockages in the outlets of the oxygen spreader. So if you have blockages, you want to have your balls loosened up. In that case, it's time to do some maintenance to remove the blockages. It is also important to know how you can lead your flow meter. So you have to take the leading of the flow meter at an eye level and measure at the middle of the bore. In this case, if you are using a flow meter which has a bore, it's always recommended to take your leading at the middle of the bore. Now let's look at how we can test our flow spreader. It is recommended to set the flow rate of our oxygen source at a higher flow rate than the recommended flow rate when you're using flow spreaders. This is very important to cover for the flow losses that may happen due to the tubing that is connecting the flow spreader and the oxygen source. We also have some resistances in the flow tubing. So to cover for these losses due to resistors, it is recommended to set our oxygen source at a higher flow rate than the recommended one. When that is done, it's time to alter or change the valve flow of each and every flow regulator on the flow spreader. This will depend on the patients that you have and the demand for oxygen for each and every patient. So you may need to adjust each and every regulator depending on the patient that you want to connect to it. When using oxygen spreaders, it's important to take some of the following notes. The following note is that the flow spreader will never deliver more oxygen than the concentrator or the oxygen source is capable of supplying. What I'm trying to mean here, if you have a source that is delivering, say, 8 liters of oxygen per minute, and you have a flow spreader that has 5 outputs, and each output is taking 2 liters per minute, you have a deficit of 2 liters per minute. And in trying to cover for this deficit, you may raise the source flow rate. Consequently, you have alarms on the oxygen source of low oxygen supply. So we do not want to reach this case of alarms. So always make sure that you have an oxygen source which is matching your flow spreader. Another important note is that changing the flow rate on one patient may have an effect on the regulator or the regulator of the other flow meters. So always make sure that you have done necessary changes to other flow meters when you have changed flow rate on one flow meter. Now, if you have no patient connected to the flow spreader, it's important that you turn off your oxygen source. So this will help you to avoid unnecessary power losses. And of course, we know oxygen may be flammable. So to avoid accident and stuff, it's important to turn off your machine. And the last note is that if you're using a humidifier bottle to deliver oxygen to your patient, always connect this bottle between the oxygen spreader and of course your patient. Don't connect humidifier bottle between the oxygen spreader and your source of oxygen. So you have moisture which will be flowing to your oxygen spreader, causing lasting and the accumulation of dust that will form in the oxygen spreader. To avoid that, you have to connect the humidifier bottle between the patient and of course the flow spreaders. From now, My friend Brenda will take you through the joint care of oxygen splitters. Thank you.
I'll take you through the general care for oxygen splitters. First of all, you have to follow the manufacturer's guidelines and instructions for specific care of different oxygen splitters. Secondly, you also have to ensure cleanliness of oxygen splitters. For instance, you have to keep the oxygen splitters clean and to prevent buildup of dirt, dust, and other contaminants that may lead to obstruction of oxygen flow. Mouth soap and water solutions should be used to clean the device, as harsh chemicals and abrasives might cause damage to the device. Thirdly, we also have to perform visual inspections regularly to check for any signs of damage, such as cracks, leaks, or loose fittings. If any of these issues are found, you should contact the manufacturer or a qualified technicians for further assistance. We also have to ensure secure connections, such as of tubings and fittings. This is because loose connections can lead to leaks and inconsistent oxygen flow, which might compromise the effectiveness of the oxygen therapy. It is also important to replace damaged parts, such as the tubings or connectors. For using damaged components might pose different risks to the patient and the caregivers. Some of the risks may include reduced oxygen delivery and safety hazards such as fire. It is also important to follow the oxygen source guidelines. That is, we have to ensure that the oxygen source supplying the splitter is properly regulated and meets the required specifications. We also have to ensure that the pressure and flow of oxygen source should be monitored so that it remains within the recommended range for the specific oxygen splitter model. We should also ensure proper storage of oxygen splitters, especially when not in use. These devices should be stored in a clean and dry area that is protected from dust and direct sunlight, extreme temperatures, and moisture. We can also refer to the manufacturer's recommendation for storage conditions if they are provided in the manual. Then lastly, you have to perform periodic maintenance, as some of the models of oxygen splitters require periodic servicing. You can also refer to the device manual to determine if any specific maintenance procedures are provided, and also to check for the recommended intervals for such maintenance. So this is all I had, and my friend and Boniface will take you through the operation problems and their solutions. Thank you.
Thank you so much, Brenda. My name is Boniface Kaseka. I'm a biomedical engineer, and I'll take you through the common problems and possible solutions that we encounter when using oxygen flow splitters. So, as I've already said, the maintenance, repair, and troubleshooting of such devices, that is an oxygen flow splitter, is done by biomedical technicians as well as engineers. And for them to function properly, they need spare parts as well as tools. So I'm going to talk about some of the spare parts as well as the tools that biomedical engineers and technicians use in order to do maintenance on oxygen flow splitters when there have been problems. So we have something like, we have gauze, which is normally used for cleaning. We have a flow meter, which is one of the spare parts that normally has problems. We have zip ties, which are used to tie tubings whenever there's a loose fitting. So we have forceps, which is used to handle the gauze or sometimes the cotton pads. And we also have screwdrivers, which are used to open the oxygen flow splitter and the flow meters. So next, I am going to talk about several problems that the common problems that are encountered with the usage of oxygen flow splitter. So I'm going to talk about problems. I'm going to talk about the possible causes, and I'm also going to talk about the solutions that technicians use in order to tackle these problems. So the first problem the first common problem that is encountered is when you have no oxygen flow from an outlet port. So it could happen that you want to use an oxygen flow splitter and you have opened using the knob, but you're not getting any oxygen from the outlet or any other outlet port. So the possible cause for such a problem could be that there's a problem with an oxygen source connection. So when we talk about the oxygen source connection, you are talking about either oxygen concentrator, or you're talking about the piped oxygen. You are also talking about the oxygen cylinder. So if the connection between the oxygen concentrator and the oxygen flow splitter, the inlet that is, then if there's a problem with that, then that means the oxygen flow splitter will not be getting oxygen. As such, you cannot be able to produce any oxygen. And sometimes it can also happen that the internal tubing, there's some displacement or some loose fitting. So which means that oxygen is just escaping, and it's not getting out into the outlet tube. So those are the possible connections. Those are the possible causes for such problem. So next slide, I'm going to talk about the possible solutions that you can use to tackle such a problem. So first and foremost, you need to make sure that the oxygen source that you are using is switched on. That is in terms of an oxygen concentrator. Make sure that it is switched on and it is in good working condition. Because if it's not in good working condition, there's no way you are going to be delivering oxygen into the oxygen flow splitter. So make sure that it is on, and if maybe the power source, or you can also check in the mains if there's power, that is, make sure that the oxygen concentrator is on. And if you're using an oxygen cylinder, make sure that the cylinder has oxygen inside. So because if you don't have an oxygen inside the cylinder, then there's no way you're getting an oxygen into the oxygen flow splitter. You also need to make sure that the connection between the source and the flow splitter is not loose. So if they make sure that the Christmas tree is not broken, or there are no any damaged or loose connections between the oxygen source or between the tubing and the oxygen flow splitter. So those are the possible solutions that you can have for this problem. Next slide, we're going to look at another problem. So sometimes you may have that the flow meter bore is fluctuating when the flow rates are adjusted. So for example, you may be in a scenario where you want to deliver, let's say 1.5 liters per minute of oxygen to a patient. So instead of the bore resting at 1.5, it is fluctuating between, let's say, 1.3 and let's say 1.7. And that is a problem, because it means that you're not delivering the precise amount of oxygen that that patient needs, and that can be fatal. So there are several causes that can lead to such a problem. But the main one could be that there's an internal leakage. It could be that there's an internal leakage either in the oxygen flow splitter, the tubings, or else if sometimes you're using an oxygen concentrator, if the oxygen concentrator has a leakage inside, then its ability to deliver oxygen to the oxygen flow splitter will be compromised, and as such, you cannot have a stable flow of oxygen into the oxygen flow splitter. So those are the possible causes. And the next slide, we're going to look at what are the possible solutions to that problem. So first and foremost, you need to make sure that the combined flow rate during use does not exceed maximum capacity of the machine. What we normally mean here is that if your total combined flow rate from the oxygen flow splitter, for example, if it is 8 liters per minute, but you are using an oxygen concentrator which has a maximum outlet of 5 liters per minute, then you are going to have a problem, because you are demanding more oxygen from the source, and the source is giving you less, and as a result, you will be having those fluctuations because it cannot give you, it won't be giving you 5 liters per minute when you actually need 8 liters per minute. So you need to make sure that, and it is recommended that when you are using an oxygen concentrator, and let's say you want 8 liters per minute, but you have, let's say you have an oxygen concentrator which has 10 liters per minute, you need to add at least 1 liter per minute to the combined flow rate of that oxygen flow speed. So if you have an next 8 combined flow rate, then you need to set your oxygen concentrator at 9 liters per minute, because so that the other 1 liter per minute can compensate for the losses that are happening due to the length of the tubing and other losses. So you also need to make sure that check that the internal tubing and the connections of the leakages and detached fittings are okay. So you don't want to have any leakages. And you can do that by just applying soapy water. So what you normally do is you switch on the apparatus, you switch on the oxygen concentrator, and you open all the outlets of the oxygen flow speeder. And you open the oxygen flow speeder inside, and then you apply soapy water. If you have, for example, bubbles that are appearing, let's say where there's a connection or where there's a tubing, it just simply means that there's leakage right there. So you need to fix that. So if you see at a connection, there's a connector somewhere, we just normally use the zip ties. So we use the zip ties and make sure that it is tight. And if you apply the soapy water and no more bubbles are appearing, then that means it's okay. But if it's a tube which has problems, then you just need to replace it with a proper one. And also you need to make sure that the tube that you're replacing with is compatible with the model of the oxygen flow splitter. You need to check with the manufacturers and make sure that those things are compatible. So next slide, we're also going to look at another problem that is very common. So sometimes we might have a flow meter ball that is missing or stuck at the top of the flow meter. So in terms of flow meter ball that is missing, it can happen that the oxygen flow speeder fell down, or there was an accident of some sort, and the flow meter is cracked. So normally you would lose that ball, and if you do not have that ball, then there's no way you can tell whether you are administering the correct amount of oxygen to a patient, and that is not ideal, and that is fatal. Sometimes you can have that the flow meter ball is stuck at the top. This could be due to the accumulation of debris and moisture inside the flow meter. My friend Goodluck explained that when you want to connect a humidifier, you don't connect it from the oxygen source. You need to connect it after the outlet of the oxygen flow speeder. The reason is because if you connect it at the oxygen source, then there will be moisture inside the tubing, and there will be moisture inside the flow meter. And when there's tubing and there's the accumulation of dust and other debris, then that will lead into friction. And friction with the ball, it means that the ball cannot move. And that was what we call it to be stuck at the top. So we're going to talk about some of the possible solutions that you can have when you have encountered this problem. So the first solution you can have is to make sure that you disconnect, disassemble, and clean the inside of the flow meter with gauze. So this is simply just to remove the dust and to remove the moisture, and as a result, to decrease the friction. In terms of when the flow meter that is cracked, just make sure that you have a spare flow meter and you replace it, but also make sure that the specifications are in line with the manufacturer's guide. So you need to check with the manufacturer for that particular model and make sure that the flow meter that you are using is compatible with it. Yeah, so lastly, I'm going to talk about another problem that is very common as well. So sometimes you may have an oxygen flows from some of the outputs, but not on others. So you can have two outlet ports which are not producing oxygen. So this can be caused by blocked oxygen ports, or maybe there's an internal displacement of the tubing. So sometimes due to dust and other debris, they may block the oxygen port. And that is also not good, because it means that you'll not be servicing as many patients as possible. So we're going to look at how you can solve such a problem. So what you can do is you need to clean the outlet port with forceps and gauze. Sometimes we can also use cotton buds, they are good as well, but just make sure that you have soaked them into 70% of alcohol. We normally use alcohol just to make sure that we do not infect the outlet port with germs. So because you are delivering oxygen to patients, and you don't want to infect them as well with other microbes, dangerous microbes. You can also check if there's an internal tubing problem. You can also tie them. We're using zip ties. If it's a tube, then you can just replace it with a new one, which is also compatible, and just make sure you check with the manufacturer's guide. So having reached there, I have exhausted what I had. Thank you for listening, and over to you, Mavi.
All right, thank you very much. Good luck and your team for that wonderful presentation. There's a lot of information that has been shared, lots of things to learn from the presentation that has been given. So now I'll invite questions or comments from the audience. So if you have any question, you can just raise your hand, and then if we have a long queue, then we wait for the next person to go. But yeah, we can come off mute and then ask our questions. So if we have any questions, please, this is our time to ask those questions. Okay, so we have a hand from Raphael. You can come off mute and ask the question, please.
Okay, thank you very much for this wonderful presentation. I'm Raphael, an advocate officer for Oxygen Alliance based in Zomba, Malawi, southern region of Malawi. It was a nice presentation. In fact, even the users in the hospital, the nurses, clinicians, they would have at least benefit from this presentation. From my side, I just want to know, in neonates, we use what we call a CPAP machine. Is it the same thing with the oxygen distributor, or maybe it's another name? The CPAP machine and the oxygen distributor, what's the difference? Thank you.
All right, so our technicians, anyone can take up that question? All right, so we have a comment in the chat from Michael saying it's not the same. Michael, do you care to expand more on that? Maybe just give a brief description.
Hi everyone. It is not the same. A CPAP is a device that provides the patient with continuous positive air pressure. But what we are discussing in this today's presentation is more of an oxygen splitter, which does not provide the same services as a CPAP. It just splits oxygen so that to maximize on oxygen utilization to multiple, or rather for multiple patients. Otherwise, a CPAP cannot do the same. Thank you.
All right, thank you very much, Michael. Kelvin, you also have your hand up. You can come off mute.
Yeah, so I just wanted to add on what Michael already explained. So a CPAP machine is primarily used to treat sleep apnea. So sleep apnea is a condition where a person's breathing repeatedly stops and starts during sleep. So a CPAP will deliver a constant and steady air pressure through a mask, and this helps to keep the airway open and prevents the interruptions in breathing that are associated with sleep apnea. Thank you.
Thank you, Kelvin. Any other additions to that? Yeah, so Michael has also added in the chat that it also addresses RDS in babies. Any other questions or comments from the audience? All right, we have a hand from Kowinda. Go ahead, Kowinda.
Yeah. So regarding CPAP machine is a machine that delivers continuous pressure. Means it is a therapy for obstructive sleep apnea, right? It has a range of pressure from a minimum so 4 centimeter of water level to 20 centimeter of water level. And in case of RDS, we can say that is a bubble CPAP that is specially manufactured for neonates, right? So that is having a low pressure range, very much low. So in case of splitters, we can say it is splitting oxygen means, no? If a delivery of 10 liter of oxygen, it is split into 5 parts as was explained in the presentation, right? So CPAP means CPAP is delivering air, normal air. In that only 21% oxygen, 78% nitrogen and other gases. But the oxygen splitter is delivering oxygen, pure oxygen, right? Thank you.
Raphael, you have a hand up. You can come off mute and make your comments.
Yes, I'm just saying thank you very much. It's clear now the difference of the distributor and the CPAP machine. So it's CPAP we used only on the neonates and it's just this not working the same like the other machine. So I've got it. Thank you so much for the comments.
Great. Thank you, Kowinda, for that. Any other questions or comments from the audience or the other technicians on the same issue or on other questions that we might have from the presentation that was given?
Hi everyone, I have a question on this, on the connection of the splitters. Does it mean that if you want to use any of the, maybe one or two of the splitters, should you open the flow meters for all the valves, or are they connected inside? How are they connected, in series or in parallel? I want clearance on that. Thank you.
All right, thank you for that question. Our technicians, I'll throw it over to you. Anyone who is ready to take up that question, you can just come off mute. Kelvin, do you want to take this one?
All right. So can you repeat the question again?
I'm asking that should all, when you're using two, maybe there are four connections, there are 4 ports, outputs on the splitter. Let's say you have a splitter with 4 outputs. Should all the outputs be at least open, or you can close? Let's say from splitter, let's say there are 4 splitters and you want to use the last splitters from the counting from the oxygen entering to the splitters. Is it a possibility that you can close some of the splitters and just open the specific ports that you want to use, or all the outputs of the splitters have to be open for you to use any of the splitters, for you to use any of the ports?
All right. Thank you. I did not understand at first. I thought you had more than one oxygen splitter. I was not thinking about the number of ports. So inside the splitter, the pipes are connected in parallel. So it means that if one port is closed, it does not affect any of the other ports. So the parallel connection will ensure that the flow of oxygen is distributed evenly, so among the outlets. So each patient will receive the required amount of oxygen therapy. So if the pipes were connected in series, the oxygen flow would have to pass through each outlet sequentially, and this would potentially result in inadequate oxygen supply for the subsequent patients. I hope that answers your question.
Exactly. Thank you.
Okay, great. Thank you, Kelvin, for that. And also, Michael just added in the chat that the flow meters can be used independently. So yeah, this is all in support of what Kevin has just said, that these flow meters are connected in a way that you can operate them independently. So it's just an issue of when you are setting up your oxygen source, if you know that you are going to use fewer outlets on the splitter, then you just lower the flow on the oxygen source. So if you're only going to use 2 outlet ports, which all require 2 liters per minute each, so that's just 4 liters per minute of oxygen required for the splitter, then you can lower the flow rate on your source, whether it's a cylinder or a concentrator, down to 4, just so that it matches up with whatever output you're going to get. Do we have any other comments or questions that we need to make before we wrap up? Okay, it seems we do not have any questions or comments. So reaching this far, I'd like to thank you all for joining us in today's call. It was a really wonderful presentation, and we'll be preparing more presentations like this for you in future, and we'll be sending out invitations according to the schedules that we'll be producing. So our next talk is coming up. We'll also share with you the topic that we're going to be presenting on. Just to give you a hint, we'll also have another topic on PSA plants. So please make sure that you don't miss out on that call. And as I mentioned at the beginning, we have a Facebook page, a YouTube channel, and a website. Please make sure to visit our platforms. We have a lot of content that we have been producing for the past couple of months. So if you happen to have missed any of the sessions, you can always catch up from either our Facebook page or YouTube channel. We'll also soon be releasing a maintenance video, so please be on the lookout for that. So once it's been released, we are going to share those links with you. All right, maybe before we wind up, I see we have another comment in the chat, so maybe let's address this before we wind up. So there's a question saying, is the oxygen splitter recommended only for pediatrics and neonatology? Or technicians, please take this one up. Or anyone who is willing from the audience can take this one. Yep, go ahead, Kelvin.
So the flow splitter can be used on anyone, but the only constraint now is the flow range. So if you are administering oxygen to an adult, for example, if they require more than 2 liters per minute of oxygen, then I think the flow splitter would not be ideal for that application. Yeah, you could you could connect the outlet ports of the flow splitter. Say you want to deliver 4 liters per minute, you could connect 2 outlet ports with a tubing, but that would be very cumbersome. And it's better just to use an oxygen concentrator if the flow requirement is above 2 liters per minute. I hope that is clear.
Okay, great. Attilio, I hope that answers your question. If not, you can ask for further clarification. But as I said, most of these flow splitters only go up to 2 liters per minute maximum. So since mostly neonates or the pediatric wards, they normally use very low flow ranges. So that's why these things are mostly used in the pediatrics or neonatology. All right, thank you very much for that. So reaching this far, thank you very much for joining us. And I'd like to wish you all a wonderful weekend, and we'll see you again in our next concentrator talk call. Bye.
Bye. Thank you very much.